Walk onto any modern factory floor and you'll see machines humming and operators moving at a frantic pace. On the surface, output looks high, but inside the front office, the numbers tell a different story. Profit margins are thinning and market share is slowly leaking away. This is the Red Queen effect. Taken from Alice in Wonderland, you must sprint at maximum speed just to stay in the exact same place. In manufacturing, it means your improvements are being neutralized by the market as fast as you can make them. When managers feel this pressure, they often default to the illusion of working harder. They assume the problem is a lack of effort, and they try to solve structural decline through brute force. You'll see them buy redundant machinery to bypass bottlenecks, or mandate extreme overtime to hit shipping dates. When quality slips, they simply hire more human inspectors to sit at the end of the line, manually checking every single unit. But brute force has consequences. Employee burnout leads to high turnover, and the debt taken on for those extra machines creates a massive financial burden. Ultimately, the factory becomes less efficient, not more, as the complexity of managing it all begins to spiral. This failure happens because the rules of the game have moved on. The strategies that worked in a stable, high-volume environment are no longer effective in a market defined by rapid change. Legacy factories are currently being hit by 3 disruptive waves that are dismantling the old standards of high-volume production. The first wave is the end of mass production. The old goal was to make 1 million identical items for the lowest cost, but today's customers want personalization. That single massive river of products splinters into 100 small, chaotic streams of customized matches. The second wave is the aggressive shrinking of product life cycles. A car or a phone used to have years of market relevance. Today, fashion and electronics models might only last 6 months before they are replaced. This destroys the traditional learning curve. Usually, a factory gets more efficient as workers get used to a product, but now, by the time the process stabilizes, the model is already obsolete. The curve resets to 0, and the waste starts all over again. For a factory built for scale, these 2 waves turn their size into a liability. They are too rigid to handle the constant resets and customizations the modern market demands. The third wave is supply chain volatility. The traditional lean goal of 0 inventory works perfectly in a stable world, but it leaves no room for error when global logistics break down. We saw this clearly when a single container ship blocked the Suez Canal. For factories running with 0 safety stock, a global delay meant an immediate and total shutdown of their production lines. To see how these pressures, specifically the shift towards small, customized batches, can paralyze a business, consider Siam Box and Print. They are a mid-sized packaging supplier that saw their predictable, high-volume business vanish almost overnight. Because their new customers wanted small, frequent orders with different designs, their printers had to stop 5 times a day for manual setups. Their daily timeline shows that 70% of the day was spent on changeovers, leaving only 30% for actual production. When they tried the brute force fix, borrowing money to buy more printers, they simply duplicated the problem. They had more machines, but each one was still sitting idle 70% of the time. They were essentially paying to scale their own inefficiency. Increasing speed or adding capacity doesn't help if the underlying process is the bottleneck. Without addressing changeover times, you're just accelerating toward bankruptcy. To escape the Red Queen's treadmill, a factory has to move beyond human sweat and upgrade its operational logic to prioritize flexibility over raw volume. Siam Box solved this by implementing SMED, single-minute exchange of dies. By standardizing their tools and preparing for the next job while the machine was still running, that massive setup block shrinks. They gained huge amounts of production time without buying a single new machine. They paired this process change with a technological shift, industrial digital printing. Because these machines require no physical plates, they can switch designs instantly. The bottleneck was engineered out of existence. If you want to know if your operation is at risk, start with a checklist. Are you only winning contracts by being the cheapest? Is your data trapped in silos, where sales and production aren't even talking to each other? Management must learn to distinguish between activity and achievement. Motion, sweat, and busyness are not the same thing as flow and healthy margins. As Albert Einstein famously suggested, doing the same thing over and over while expecting a different result is the very definition of insanity. Facing 21st century complexity with manual effort is a losing battle. The path to a resilient, smart factory starts with a framework that has been proven for decades: the Toyota Production System.